Hello, everybody. We are going to look at the other side of this. So we just learned about turning a percent into a decimal. And we learned that we do that by moving the decimal two places to the left. Okay, and more importantly, we learned why we do that, right? And the reason why is because percent means out of 100. So when I'm turning that percent into a decimal, like the example we used was 53%, well, if I want to make that a decimal, 53% means 53 out of 100. So just like we did yesterday, we do 53 divided by 100. And when you divide by 100, what that does is that takes a decimal point and moves it two to the left. Okay. Well, this may not be terribly surprising, but when we're going the other way, going from a decimal to a percent, we're just going to move it to the right instead of to the left. So we're still moving two places because percent is all about 100. Right? So this time we're multiplying by 100 instead of dividing by 100. So it moves to the right, and then we're going to slap a percent sign on there. So let's do some examples. So if I want to convert 0.35 into a percent, I'm just going to take my decimal point here, and I'm going to move it two places to the right. It ends up after the 5, so that means that is 35%. Okay. We don't need the 0 anymore. Okay, 35 is a whole number, 35%. All right, if this is 1.2, I'm going to again move it two places. So if I move it one place, it gets to the end of the 2, then I got to move it again. Again, like we talked about, anytime you move a decimal point over and there's no number there, you got to fill in a placeholder. That placeholder is going to be a 0, so that keeps us in the right place value. Okay. So 1.2 moved over, and that gives me 120%. Now, to point out something I mentioned at the end of the last video, we got to remember that 100% is the same as one whole, right? 100% of a pizza is one whole pizza. 100% of a class is one whole class. Okay. So when we went from the percent of 100 to a decimal, we took our decimal point at the end of the number, moved it to the left. That gave me 1. Okay. Well, the other thing I'm doing here now, I'm going in the opposite direction. So if I think about the number 1, the decimal point is at the end of the whole number. If I move it 2 to the right and fill in 2 zeros, that would give me this 100%. Okay, so that's what I'm doing here. We also talked about the fact that because 1 is equal to 100%, if you have a number bigger than 1, okay, it'll give you a percent bigger than 100%. Right? If you have a percent bigger than 100%, it'll be a decimal more than 1. So if we look at this number was 1.2. Well, 1.2 is more than 1, which means we should end up with a percent that's more than 100%. Okay. On the other hand, this was 0.35, which is less than 1. So you may notice we got a percent that's less than 100%. Okay. If I look down here at this next one, 0.015 is less than 1. Okay, there's no whole number part. It's just a decimal part. So I should get something that's less than 100%. So let's see what I get. If I take the decimal point and I move it 2 spaces to the right, it ends up between the 1 and the 5. So I can see 1.5%. Okay, and that is less than 100% like I thought. Okay, how about 4? Is 4 more or less than 1? Well, 4 is more than 1. So I should end up with something more than 100%. Let's see what happens. Okay, the decimal starts at the end of the number. If I move 2 places to the right, I got to fill in 2 zeros to hold those places. Okay, so 4 is the same as saying 400%. Okay. So 400% of a pizza would be like 4 pizzas. Right? You have 4 times as much as if you just had one whole or 100%. Okay, so same thing as we did before, we're just moving the decimal in the opposite direction. So let's kind of put these things together and talk about ordering from least to greatest. So the reason a lot of times we have to convert the forms of these numbers is so that we can decide what's bigger than what. So if I have 65%, 0.375, 4/5, and 23%, I want to compare these numbers. In order to compare them, I need to have them all in the same form. Okay, this is something I talked about at the beginning. So right now they're not the same. I have 2%, I have a decimal, and I have a fraction. Okay. Well, I could try to put them all into percents. The problem is I don't know how to do a fraction to a percent yet. I will tomorrow, but I don't know that yet. So I don't want to put them as percents. I could try to put them as fractions, but again, I don't know how to do percents to fractions. Okay. I do, however, know how to turn everything into a decimal. Okay. We did fractions to decimals yesterday and percents to decimals today. So let's list everything as a decimal and then see if we can compare them. So 65%. To turn that into a decimal, I just remember the decimal point is at the end. I move it 2 places to the left, and it ends up before the 6. Again, 65% is less than 100%, so I should end up with something less than 1. Okay? That's a good thing to remember in case you accidentally go to the right and end up with 6,500. Okay, well, that's definitely more than 1, right? So that should be a flag if we see a percent less than 100%, and then that you change that to a number that's more than 1. Okay, it's got to be less than 1, in this case 0.65. So I'll put a 0 out front for my whole number part, 0.65. All right, now the second number is already a decimal. Now I'm trying to compare these, so I'm going to line them up. Remember, when I line them up, I want the decimal point in the same spot. Okay, so point, I'll put a 0 out front for the whole number part. It's not necessary, but why not? So 0.375. All right, so I got my tenths lined up with tenths, hundredths lined up with hundredths, and I can compare these. Okay, 4/5. Let's bring that down here. I want to turn 4/5 into a decimal. Okay, so I got to do some dividing, and it's 4 divided by 5. So that trick Mr. Engen taught us is that 5 is the denominator. When I think denominator, I think dog. The dog stays outside. Okay, and the numerator is 4. That stands for Nana or nerds, which are inside. Okay, so I'm going to do some division. So I think, does 5 go into 4? No, it's not big enough. Okay, so I put a decimal point and a 0. Remember, I can put a decimal point if it's a whole number and add as many zeros as I need. I'm just going to start with 1. Okay, in my answer, the decimal point will be straight above where it is in the problem. Okay, so 5 doesn't go into 4, but 5 does go into 40, and it goes in 8 times. 8 times 5 is 40. That means it went in exactly with nothing left over, so I'm done. Remember, anytime you're turning these fractions into decimals, you'll either have this happen where there's nothing left over and you're just done, or you'll end up getting the same number over and over and it'll repeat. Okay, in this case, this was one that ends, and that's 0.8. So I'll do again a 0 for the whole number part, 0.8. Okay, the last one is 23%. Well, again, I can take the decimal point at the end of the 23, move it 2 to the left, and I end up with 0.23, so 0.23. Okay, now if I compare, remember I'm comparing starting from the left, I'm going from the highest place value to the lowest place value. And the first time they're different is going to tell me which one is bigger. Okay, so if I look at the ones place, they're all zeros. Okay, all these numbers are less than 1 whole. So these are tied at this point. Okay. If I go to the next place, the 10th place, I got a 6, a 3, an 8, and a 2. All right, so that's nice. All 4 of these are different. Okay. If any of these were tied, I'd go on to the next decimal place for the tiebreaker. But these are all different, so I can tell just by looking at the 10th place which is smallest. The smallest here is the 2, so that means 0.23 is the smallest. Okay. Now, as a rule of thumb, if it tells you to order these numbers from least to greatest, you might be changing the form of these numbers as you figure out. But when you give the answer, you should use the numbers that you're given, right? Because the idea is that you can tell of these 4 numbers which is the smallest. Okay, well, the 0.23 is what I got from 23%. So in my answer, I'm going to call that 23%. Okay. The next smallest, that one's done. The next smallest would be the 3. So 0.375 is this decimal. So 0.375 is the next smallest. Got that one. Okay, then between these two, we got a 6 and an 8. The 6 is smaller, so 65% is next. And the biggest of the 4 is this 0.8, which was 4/5. So from biggest to smallest, we have 23%, 0.375, 65%, and 4/5 in that order. Okay? All right. I'm going to leave you with that. You'll be doing a little bit of that in your homework. At this point, please finish off the second half of your homework where you will be turning percents into decimals, decimals into percents. Don't forget to add the percent sign and comparing numbers that are in a couple of different forms. Good luck.